Good evening, everybody. I hope you're doing well. This is Doug. I'm your host for tonight. So thank you again for joining us for the Soil Health Field Day at Red Shirt Farm with Jim Schultz and Dan Kittredge. We are really looking forward to hearing more about the soil health practices that Jim is using and the way that Dan is working with the Bionutrient Food Association to connect soil health and the quality of food. So tonight we have funding from the United States Department of Agriculture, Natural Resources Conservation Services, and just want to thank them for that. Before we get started, I want to take a moment to remember that we are all coming from land that was previously occupied and inhabited for a long time before European colonization. And this is a moment to honor the people who came before us. I'm coming from what was Pawtucket land and in the town of now South Hamilton. And we do honor the people whose land we now occupy. And so we should all think about how we can move forward and rematriate our lands in an equitable way.
Thanks, Doug. Yeah, hey everybody. Thanks for coming. My name is Jim Schultz, and with my wife Annie, we work the land that we're on, which again was from, as Doug pointed out, from people before us, the Mohican people. So we've been here since year 2000, and slowly developing the land for the last 20 years. We're now farming on 13 acres, 2 of which is intensive cultivation for vegetables. We use about 4 to 5 acres for pasture for our animals. And then the rest is mixed flowers and herbs and housing and that kind of thing. So yeah, we're fortunate to have the support of NOFA for all these years that we've been starting our farm and getting going, and for Dan and his Bionutrient Food Association for all the help in getting our soils up to snuff. So thank you all, and we'll be talking more later. So I'm interested to hear more about the rest of you guys.
And Dan, welcome. Would you like to introduce yourself a little bit?
My name is Dan Kittredge. I'm the Executive Director of the Bionutrient Food Association, also leading the Real Food Campaign, a longtime organic farmer, connected to NOFA since the mid-1980s. So really excited to be here tonight.
All right, so at the moment I will get started and I'll queue up a little video overview of Red Shirt Farm.
So yeah, just a brief overview. We're on 10 acres, extends from Route 7 to the back North Main here. And then we lease the bottom 3 that are down over there for pasture for our animals. We have about 2 acres under cultivation for beyond organic vegetables. And then we also raise pastured heritage chickens and turkeys and pigs. And we breed our turkeys and pigs. They're heritage breeds that are considered endangered by the Livestock Breeds Conservancy. And we're trying to kind of bring them back and preserve their genetics, while also reintroduce people to what food used to be, how turkey and chicken used to taste before Cornish cross and broad-breasted white. So we've been working the land slowly for 20 years, but really intensively for more like the last 7 or 8. Gradually improving what we have. This was all overgrown. Just the little area around the house was mowed, and then everything else was kind of grown up, and so we found there's junkyards and things scattered all over the place, and had to get that all cleaned up. So we are in a permanent raised bed system for our vegetables. We use organic practices. We're not certified organic. We also use biodynamic, and we've incorporated some permaculture aspects into what we do as well. So as we walk around, I'll kind of talk about how we establish things. Yeah, we have basically 6 different plots. Because we're on a hill like this, and we don't have one beautiful, nice flat area, we've had to kind of develop where we can. There's some terrace beds over there we'll be looking at, and little plots all over. And it's gradually kind of grown as we've gone. So what's interesting to note is how the quality of the produce changes depending on how long the soil has been worked, and the practices that we've used as we went along. When we first started out, we knew we'd never be, well, we didn't have enough resources and we didn't be big enough to have to be doing tractor farming, nor do we need that. So we use a BCS, which is a walk-behind tractor, which is really, we'll be looking at. It's very common in Europe and small bed systems.
For whatever reason, if the microbes weren't working well in the soil or the plant wasn't healthy and it couldn't access what it needed to make each leaf work as well as it could, it's like a solar panel working at 20% of effectiveness as opposed to 80% effectiveness. By simply adding those things to increase that photosynthetic capacity, you basically stimulate the overall process. So, seems to work.
Right. What we like about the caterpillar tunnels is the ability to move them from place to place. So every year we can have them on fresh soil, and that's been just fantastic. The high tunnels, I couldn't live without them, but we're starting to have, you've got a honeymoon period of like 3 years, I'd say, before you start to have some serious issues. We also have solar wrap. This is a bubble material that's been used in Germany, or it started out in Germany, it's been used in Europe for 25 years. It doesn't photodegrade, and it doesn't require a fan. This has to have a fan running basically 24/7 for most of the year to keep the plastic inflated. So the solar wrap doesn't require that. It's a static composting system, so you don't have to turn it. So yeah, within a year it breaks down, and what's different about it is that it's almost like a paste. This is more like an inoculant. So we've tried spraying this on, and we also, in the end, we ended up just taking and just like we put on our other amendments, we just distributed it across the top of our beds.
Compost that is turned, in the process of being regularly turned, functionally it does the same effect as the tillage, which is it creates a dynamic where most of the microbes in there are bacteria, not fungi. And so when you apply a bacterially dominant compost to your fields, you're not necessarily getting that fungal ecosystem that we understand correlates with carbon sequestration, et cetera, et cetera.
This is our little orchard here. We've got about 40 some odd trees, some mixed varieties. They're all on native rootstock. None of them are dwarfs. Peaches, pears, Asian pears, apples, cherries, a couple, some chestnuts at the end. We put these in on a Burman swale, and we used the hugelkultur method. So.
So that was just a little recap of some of the things that we were doing on the farm a couple weeks ago now. And I think we're just gonna jump right into the content for tonight, and starting off with talking about Jim's raised beds. Jim, would you like to talk a little bit about your raised beds?
First, I guess I should back up a little bit and say that we are a regenerative no-till farm, but I guess no-till really has a range. It is a continuum, everywhere from reducing tillage to outright not tilling at all, not putting metal against the soil. I'd say we're on the minimal to no-till range, somewhere in there. We do use, as you'll see, a BCS with some implements that do disturb the soil somewhat, but we try never to go anything. We're never inverting the soil after the first time we break ground, and we try to minimize the any disturbance below 2 inches. We'll talk about some of our small-scale minimal till methods, and one of them is our permanent beds. So when we first started out, we were on a pretty much almost an annual basis tilling and recreating our beds. And when I was an apprentice way back, 30 years ago, the farms that I was working on, that was the method that they were using. And so I, just continued in the methods that my mentors showed me. But we realized pretty quickly that our, soil health was just not what it should be. We were getting, constant crusting. I wouldn't say we had a plow pan, but we definitely didn't have the tilth that we wanted. So we shelved the tiller and moved to a permanent bed system where we create our beds once, and then the walkways are permanently there, and all we're doing on an annual basis is either broad forking, or every other year we're raising the beds up again. And the reason we like the raised beds is for a few reasons. One is our soil type can stay pretty wet later in the season if we aren't using our raised beds. So we feel that we get better moisture management, so they're drying out quicker, they're warming up faster, and just because of the amount of people that we have visiting the farm, our CSA, we have a 100-family CSA. We have a lot of pick your own. The gardens are open to our members. We have volunteers. We have new apprentices coming through all the time. So just the simple fact of having a raised bed and defining that bed and defining the walkways very clearly just helps in pure logistics. Managing people and whether they're not going to be walking on the beds. And another factor is just the fact that the beds are raised. We're about 6 inches. We're that much closer to when we're working our beds. We're bending over 6 inches less to get what we're doing. The walkways we manage those with mulch, and that's on a sort of a biannual basis. Right now in these beds here, you can see the beds are not raised that much. So this is kind of going into the second year. The beds have sunk a little bit, and so we mulch the walkways with hay, a mulch hay that we create, and you'll see that a little bit later. So that the next year when we do raise the beds, the hay acts as sort of like a sheet compost. It's broken down in the walkways, and we'll be kicking that up on top of the beds. So it provides organic matter and material to raise the bed with. In the first year after we raise the bed, you can see the piles of wood chips in the back. Those wood chips are used in the walkways to keep weeds down, and that's the primary reason, but to conserve moisture, and also to as the wood chips break down and the fungal material and the hyphae start to grow, it can grow into the beds there and provide that resource for us. So those wood chips are composted for a minimum of a year, sometimes 2 years. They're then applied in the walkways for another year, and then the following year they have broken down enough that we may kick them up if we need to raise the beds. Otherwise, we'll leave them in place and then mulch that second year with hay, as I said. So that's kind of a raised bed system in a nutshell. Those beds we are broad forking once or twice a year, depending on the crops that are in there and how long a season they're in there. Most all of our beds are double or triple cropped, unless they're in a long season crop like a kale or a chard. We're amending with compost on an annual basis, sometimes twice, in between crops, depending on what was there before. Or if it was a heavy feeder, we may be putting on alfalfa meal or a Crayers, which is a composted chicken manure, 5-4-3 organic, to give ourselves a nitrogen boost. We also use Advancing Eco-Agriculture, John Kemp's company's products for amending our soils. But I'm kind of getting off track here. This is, again, those are our raised beds there. It's one of the things that, we go back and forth on, and some people, aren't a fan of raised beds for a couple reasons. One, you can see on the right-hand side, this is not a raised bed. This is another farm. And it does allow you to keep your beds a lot closer. With a raised bed, you've got a shoulder on either side, and we're raising those beds with the BCS. So our walkways are actually close to 18 inches. If they weren't raised, you can, some people are doing like a 12-inch bed. And the argument for that, not raising them, is that you can have your beds closer. In my opinion, having that extra space for putting your bins, for providing aeration, and simply having raised bed is well worth it. We might gain a bed or two at most across any of our plots by not raising them. But again, we feel that the benefits there. So the downside is that. So this is part of another presentation, but just some things to think about when you're shaping your beds is consistency and having a standard. We're on the standard 30-inch bed system. And this kind of just outlines what I said, that, with wider beds and aerial pathways, you have more growing area. But, we've decided on the system that we have that it works well for us. Yeah. So one of the things that has really evolved a lot since I've been working in the field, so to speak. As I said, I started out as an apprentice way back when I was 19 and 20, which was almost 40 years ago now. And back then things were, we just didn't, the information wasn't there, the tool sets weren't there, and the ideas weren't really starting. So Elliot Coleman, I think probably is the sort of the grandfather of our methods, and it brought over a bunch of things like solarization and occultation. So using plastic materials for mulching, scuttle hose, time readers, the BCS, all that kind of thing. One of the tools that he also brought over from Europe that we use extensively is the Flame Weeder. And that's been a game changer for us in terms of stale seed bedding and allowing us to not spend so much time waiting for weeds to germinate to kill them before we can plant into them. So stale seed bedding is just a concept of getting rid of the weeds before you plant your crop. And you can do that with tarping. You can do that by germinating seeds ahead of time and then terminating them through scuttle hoeing or, in this case, flame weeding. So one of the ways that we have found that we can speed that up is by sort of a biomarker for timing. So when we do our carrots, we'll put our carrots into a bed that does have weeds in it. And we'll also plant at the same time beet seeds, which tend to germinate about 2 days ahead of carrot seeds, regardless of the temperature. So, early in the season, both of them may take a couple weeks to germinate. In the middle of the season, they may take as few as 4 to 6 days. So the beets are always 2 days ahead of the carrots. So as soon as we see the beets, we pull out the flame weeder. The weeds that have germinated in that time, we can terminate with the flame weeder. And then when the carrots germinate a day to 2 days later, they're germinating into a stale seed bed, a weed-free bed. So flame weeding we use for our carrots, our arugula, and some of our lettuce mixes and Asian greens mixes, the fine seeded crops, to terminate weeds ahead of time. There's a great company now, Farmer's Friend LLC, that has a whole variety of tools that are geared to a small market farmer. But one of them is they've kind of really perfected the flame weeder. This is their product there. Okay, sorry, let me get ahead to the tools here. Okay, so one of the things with our methods is that we try to let biology do most of the work. But there are certainly a lot of times when we have to use our tools, and one of the main ones we use to loosen our soil without turning it over is the broad fork. Probably a lot of people are familiar with these. There's a whole range of different types. Some of them are better for hard ground, some of them are better for covering the entire bed. But basically what it is tines on a sort of a U-bar that you step into the soil a foot or so and then pull back gently to aerate the soil and loosen it up without turning it over. Johnny's bed rake is one of my favorite tools. I had to put it in there. Great for bed shaping. We've just started to use the gritter in the years. This is a tool from NeverSink for bed marking. And we used to just use a rake with little hose pieces on it to mark the beds, but this is fantastic. And it comes in a bunch of different sizes, different shapes. The Flex Time Meter, we've been trialing this year. We're not so sold on it. Essentially, it's a tool that we use to get the reads at what they call the wire stage. So you put over tops that are up and get them. And it works. We used to use just a mower to when we wanted to clean off the bed, or a weed whacker. So these are still in the arsenal, but we don't use them that much anymore. So this is the BCS. BCS is a walk-behind tractor. It's a two-wheel tractor that can take a number of different implements on the front or the back. And right here, we're just going to show you how we use it to create our own mulch. So mulching is a big part of our system. We used to bring it in, buy in either straw or hay. And we just, with the straw, one, it was expensive. Two, we could very rarely find organic straw. Most of it was straw that had been terminated with Roundup. So if you guys, when you get your straw, if the straw looks like bright, like sort of a yellow, like a consistent bright yellow kind of color, that's been terminated, usually with glyphosate, Roundup. And you know, you're applying that. The mulch is a good thing, but the residue that's on it is not. With the hay that we were getting, it's very inconsistent in terms of, well, one is you never knew whether or not the farmer that was growing the hay, that was mulch hay, was growing it for somebody that wanted it to be weed free, like horse farmers. So that would be applying some sort of herbicide to the field or chemical fertilizer or whatever. So anyway, the point was we had a hard time finding good mulch. So we started to use, we had pasture that we need to manage, and we didn't have a good way of doing it until we came up with this. We found this tool set. So this is BCS with a hay rake, with a Sickle Bar Mower. So the BCS, this is a gas-powered 853, which is one of the bigger BCSs, which right now it's not that big. This is the Sickle Bar Mower. So we're able to go through our fields and cut at ground level just when we want to. So in this case, we got about 6 to 8 inches of growth on there, and we're cutting that. So you can see we raise poultry with similar mobile houses. Once we cut it, we need to rake it into windrows. This is a hay rake, and simple device, kind of fun to use. It's just throwing the hay against that stop and creating a windrow. Once we have, you can see it's pretty mobile, pretty flexible. You do have to go in one direction, obviously. So once we have those windrows all formed in the field, the hay's been cut, the windrow's been formed, we come in with our baler. So this is a small round baler. And if you've seen the big round baler, it's exactly the same concept. It's being pulled into some rollers that are creating sort of layers, concentric layers that are then going to get wrapped in the end. And that one downside from my perspective is that the plastic that's involved. It's just a plastic mesh, which I think it's a perfect device except for the fact that you've got this plastic involved. So once it's full, there's a reel on the side that tells you it's full. We engage the wrapper, which wraps the round bale. and there's a finished bale. So they range depending on how thick the hay is, from about 25 to maybe a 35-pound bale. And the nice thing with our system is once we have a round bale, we can roll it out into, we use this as a mulch in our walkways. It also pretty much fits on top of the bed. It's about a 26 inch bale. So it's perfect in our beds because we want to be getting the shoulders covered as well on our raised beds. So you can see it's a lot quicker to roll that out than it is to take a square bale and to take flakes and to try to shake them out. So that's our system sort of start to finish for transferred mulch from our property. The Rotary Plow is another tool that is sort of an integral part of our system for creating the raised beds. I didn't have any videos, so I just stole this.
Another tool that I really appreciate in our tools is the Rotary Plow. And
who's going to be using this. And so this tool, there's two different kinds of rotary plows. This is a single bottom, so you have to go in one direction the whole time. The double bottom plow, which we have, allows you to move in either, you don't have to worry about which direction you're throwing the soil because you can turn the plow so that it's kicking soil one way or the other. So right now he's kicking up the walkway on top of the bed, which is what I was talking about before. So when every other year or so, we'll go through and do this and take the material that's in the walkway and throw it back up on top of the bed. And here, in this case, he's actually using it to cover some cover crop. So Jean-Martin says that he's able to terminate cover crop this way. We haven't had that kind of success with it, but it does demonstrate pretty effectively how the tool can work to transfer soil from the walkway up on top of the bed. Another tool is the Power Harrow. And again, I didn't have my own video of this, so let's quickly show you this. We've got some photos, but the Power Harrow is a tool to really create a very fine seed bed and to do some bed shaping. So in this case, he's got his compost on top of that bed and wants to integrate it into the top inch or two of the soil and also create the seed bed. So the tool here is also a BCS implement. And what's unique about it is the tines rotate horizontally as opposed to vertically. So they're going sort of this way, but almost like your fingers going back and forth, as opposed to a tiller, which is rotating in that direction. And so he's just talking here about his broad fork. So this is attaching the Power Harrow. And you can see that the PTO just fits into each of these implements. You can adjust the height anywhere from ½ an inch down to as much as 4 inches if you want. We never go that deep. And you can see what it's doing. It's creating a very fine seed bed, and the roller on the back smooths everything out. So that was that tool. You can see how the tines are working there. Oops, I'm sorry. Jump back there. And the roller and back smoothing everything. And there you can see a close-up of the tines in action. So there's some soil disturbance. There's no question about it, but if you're gonna be seeding carrots or arugula or lettuce mix or any fine seeded crop, we just have not had good success going into a standard no-till debris covered bed. So we do our plugs into something like that, but we don't do our direct seeding. This is a tilther. This is another tool we use developed by Elliot Coleman. It's something that, if you can see on the bottom, there's an electric drill, a battery powered drill that's driving these tines right here. And that's what it's good for, is incorporating material into the beds, especially we use it in our greenhouses. So minerals and various nutrient meals, we use that for incorporation. And also it creates a very fine seed bed. We use the Jang seeder for our for seeding, but we use it not with a shoe that you see in this picture, but with a double disc opener. And the double disc opener is great in a no-till system because it's able to push things aside, push the debris aside, and create a and drop the seed in even though there's debris. So let me just jump ahead here a little bit. This is Jesse Frost. He has a no-till podcast. And again, I'm sorry I didn't have video of this ourselves, so I'm stealing Jesse's stuff here. But this is a close-up of the double disc opener in action. You can see all the debris on top of the bed. He's got lettuce stumps in there too that he'll be rolling over. And it does sometimes catch, but not nearly as much as you had that shoe. You would not that. So we're able to use this for seeding into, if we are going to try to seed into a rougher bed, this is what we would do. But for something, this would be for a larger seed. Our fine seeds, like I said, our carrot seed, we wouldn't use that for. So that's sort of an overview of some of the tools. Let me see if let me pull up the one that we didn't show, which is also one of our favorites, is the Flail Mower. So let me see here. This was a bean crop that had gotten frosted the day before the workshop. And so it wasn't salvageable. And we needed a way to incorporate the material into our bed. So rather than pulling the beans, we wanted to leave the roots in the ground, all those nice nitrogen-rich nodules, and then also incorporate the material on top. So the Flail Mower has blades that cut very close to the ground and are also chopping extensively, so all the material is broken down very finely, I think. So here we're just turning it over so you can see the blades, and
And they're able to swing around right at the soil level, and we can adjust the level with this roller. So it's if you haven't seen it before, it's like it's very different than what you're used to with like a lawnmower. So that's the Flail Mower.
We can pass it over to Dan.
Yeah, Dan, go ahead and chime in.
You're done, Jim?
Yep.
Okay. Where would you like me to start, Doug?
Well, why don't you give us an overview of where the Bionutrient Food Association comes in, and in particular the research I think that you all are doing is really sort of, giving us a pivot point where we can say the practices that we're using do have direct correlation to the quality of the food coming from those fields.
Sure. Well, I'm, a longtime organic farmer and struggled with economic viability in large part, I think, due to pest and disease pressure and sort of limited yields that came from non-optimal vitality in crops. And when I sort of started farming professionally about, I guess it was almost 15 years ago, not just managing people's farms, but trying to make a living my own self farming, realized that even though sort of organic was nice and that we weren't using toxic chemicals, we weren't necessarily working in harmony with life, and that plants weren't realizing their full potential, it seemed like. If you use nature as a model, it seems like you don't have pests and diseases and all that kind of stuff really taking things out on a regular basis. You've got sort of more balanced fecundity going on. So after a bit of studying and some practice, found that there's a bunch of things you can do that effectively create a dynamic where your plants are healthier. It all, I think, stems from the life in the soil being happier, functioning more well. I like to refer to the soil life as the bottom of the food chain. And if we think about, the bottom, the middle, and the top, the plants are the middle and we're at the top. It's only when the bottom of the food chain is functioning well that the middle is functioning well, and that's where our crops reside. So, different practices, inoculation and mineral balancing and maintaining aeration, maintaining hydration, maintaining soil cover. There's a whole suite of things you can do that sort of work to emulate nature on a agricultural productive ecosystem. And so we've been working for a long time, giving workshops, courses about that kind of stuff. And it seems that there are some really nice correlations there with plant health, with pest and disease resistance, with it seems like increased soil carbon, increased flavor, shelf life, aroma, we think increased nutrient levels. And so as an organization, we've been focusing on this nexus where these things overlap and saying, look, wouldn't it be interesting if we could organize ourselves around that? Not to say that organic is bad or permaculture is bad or biodynamic is bad or IPM is bad or anything like that. Just saying those are sort of human created structures attempting to define life, and let's use life's function as the central mode of discernment. How well is it operating? And so, you know, understanding that we have a Western rational scientific culture, we've been working to use the scientific method to verify those correlations, identify the causal dynamics, identify the variations and the benefits, et cetera. So that's all a bunch of big fancy words, but you know, the BFA in partnership with NOFA and a number of other organizations now, a few, you know, land-grant universities, some big companies, some foundations, has been working on a three-legged stool of a project that we're calling the Real Food Campaign. One leg of that stool is to identify the nutrient variation in food. We understand through our tongues that this tomato may be different from that tomato, or this carrot from that carrot, or this peach from that peach, et cetera. According to the USDA, sort of all carrots are uniform. They have the same level of vitamin D, the same level of calcium, the same level of copper. So what we have, you know, as our first objective is to identify that variation in nutrient levels. To that end, we've established a couple of labs now in North America and one in Europe to run samples of crops through. NOFA has been collaborating with us through MDAR. I think we've had 10 farms that have been sending in carrots and spinach now for a couple of years. We found some quite significant variations in nutrient levels in food. I was just reviewing our 2019 data this year, and I think it was polyphenols in carrots. Polyphenols, antioxidants are some of those compounds we've looked at that are sort of nutritive, flavor correlating, health giving. And the carrot with the highest level of polyphenols had 96 times the level of the carrot with the lowest level of polyphenols, which would mean that you would have to eat 96 of the lowest level carrots to get the same level of polyphenols as the best one we found last year. So we sampled 400, I think it was 412 carrots from across the country, organic, not organic, grocery stores, farmers markets, et cetera, north, south, east, west in the country. With elements, copper and zinc and calcium and potassium, it was about maybe a 5 to 15x variation. So this carrot has 5 times as much calcium as that carrot, or this leaf of spinach has 15 times as much iron as that leaf of spinach. With the antioxidants and polyphenols, it's more like 50 to 250x. It seems to be the variation we're finding. So stage one is, what is variation? Can we define that? Stage two is correlating those nutrient variations with management practices. And so we've been working, I think last year we had about 35 farms. This year we've got about 120 across the country that are submitting data, identifying soil type, fertility program, management practice, cultivars, all the sort of environmental conditions that were involved in the production of those crops before they sent the crops into the lab. And then we're sort of, as we sample the crop, we sample the soil the crop grew in, and then we have the data which correlates with the way it was produced. So I think that's perhaps what you're referring to, Doug, was I think I can pull up a slide here. I've got it on my computer. Let me just see if I can screen share this. So Screen share. So this is our, this is our, I guess I can't move this around, but, oh, there I can now. So spinach antioxidants, carrot antioxidants, cherry tomato antioxidants, kale antioxidants, et cetera. We can look at, on the left-hand column, you can see what was the dynamic that was claimed, and so we have many different management techniques and practices that are sort of reported. This is actually a fairly simple chart. And then across the top, you have the different compounds that were found. So this is by no means a complete chart, but shows, with the level of confidence here, this one right here was sample size was 2, so the confidence value is low. This one here, sample size is 12, confidence value is higher, et cetera. So it's a really complicated statistical framework to begin to tease out the correlations between specific management practices and specific nutrient results in crops. I think I've got another graphic I wanted to share with you. Yeah, this is the carrot one we're just working on from 2019's data that shows the variation. I like to point this out as far as, if you can see the carrot on the right, that's the one that equals in the polyphenol levels and 96 on the left. And this, we're still working on this graphic to get it fit for social media meme status. But what you can see is that the one on the right is over past 100 was the level of polyphenols in the crop. And the ones on the left, was only, just a couple samples over there. The vast majority of the samples, the 413 samples, were, between 0 and say 25. So the potential of carrots is over 100 in the polyphenols. The vast majority of what we find in the supply chain, whether it's grocery stores or farmers markets, et cetera, is a quarter of that or less. And that's really, actually a very nice bell curve. And that's what we've been finding as we continue to do the research, is that the vast majority of the crops that are available for people to eat are relatively empty from a nutritional standpoint. So, yeah, so that's stage 2 of the second leg of our stool, is identifying variation in the crops, correlating variation with the management practices. And then stage 3 is the sort of the, can you test quality? And so our idea has been that we should be able to give consumers the ability to sort of flash a light at a crop. We want to be able to get rid of the labels and the marketing. Various incentives are in place to try to market to people. In the olden days, you could take a bite out of an apple and say, is this good or not? That's what goats do and cows do and everything else, is they say, how does this feel to me? That's usually not approvable in the grocery store. You can't take a bite out of those organic carrots and say, that doesn't taste very good, I'm not going to buy them. So what we've said is, let's use a sort of a technological hack where we can effectively get that reading and still operate within the structure of the system. And so I've got a version of our handheld spectrometer here, which maybe some people have seen. And now with 2019's data in, we have calibrated it to red, yellow, green on those first 6 crops. So we can say, with a flash of light, with about 70% confidence, this carrot is in the top quartile from a nutritional standpoint. This carrot's in the bottom quartile. This carrot's in the middle 50th percentile. So yeah, that's the broad work of the Real Food Campaign, is to figure out what quality is, figure out what causes it, and then give people the ability to test it. And our thought is that if we can, in a dogmatically open source fashion, through sharing and learning and collaborating, begin to correlate some of these management practices with some of these environmental results, with some of these nutritional results, and really organize the market around quality as opposed to around volume. Most of us that are farmers still sell by the pound. We don't sell by the polyphenol. if we have a 5 or 10x variation in nutrient levels, one could argue this pound of carrots is worth 10 times as much as that pound of carrots. But really, the only variation you get when selling perhaps is by your organic certification, or if someone knows you personally and they'll maybe give you a $3 a bunch instead of $2.50. But if you're actually providing 5 times as much nutrition in that same bunch of carrots, one could argue that would be an incentive for consumers at least to start purchasing who are doing a better job and leave the crops that are of less quality on the shelf. So when it comes to the carbon sequestration piece and the ecosystem services, we are looking, the cover cropping is one of the techniques, the practices that correlates most well with increased nutrient levels. The cover crops are effectively keeping the soil life fed longer. And if we understand that it's the microbes at the bottom of the food chain that are the reason why plants are able to flourish in their natural ability, any practice or any technique that's going to facilitate them functioning more well, we assume would correlate with better nutrient levels. The real, I think, answer when it comes to these practices and techniques and trying to tease them out is it's never any one. It's never any one technique and never any one material, any product, any protocol. It's really a biological system, and living systems, biological systems are multi-factor by nature, and that's where the art of farming comes in. Is understanding the nuances and being able to see, oh, it looks like the soil's a little bit dry, let me do that. Oh, it looks like the soil's a little bit tight, let me do that. So trying to define nature in numbers is perhaps a fool's errand, but at least being able to establish a framework to begin to discern things and ideally begin to shift decision making in a way that addresses those externalized factors like soil and the environment more systemically, I think will be beneficial. So that's a short, or maybe not so short, ramble on the topic. Is that what you're looking for?
All
You're
right,
still muted.
we can go on and on, right? I think as you're pointing out, there's variations even probably between which crops are, respond better to certain practices. I wonder if your data shows any of those things.
Well, last year, so we only started this project in 2016. It was a sort of a fantasy, vision at that point. In 2017, we were able to build our first spectrometer. In 2018, we built our first lab and tested the first crops. In 2019, we began to do the data collection as far as the environmental conditions and management practices. We only had 35 farms, like I said, last year. And so to be able to get enough data on any particular practice to give you any statistical significance on 35 farms, it's really, it's a bit early. We are right now uploading the 2020 data into that same spreadsheet. So, and we've got 130 farms now in 2020. So we're going to be able to dramatically increase the size of that data set and hopefully begin to tease out some of those patterns. But it's a process. And, we are people who may be able to see what we think is the big picture, but we're not necessarily the PhD trained scientists. And so we don't necessarily envision it as our responsibility to find the answers. We envision it as our responsibility to create a structure where answers from this more biological perspective can be discerned. When we first went to the USDA in DC a few years ago and said to them, we think there's a connection here between soil health and plant health and human health, they said, so do we, but we don't think we can do it. We don't think it's possible to figure it out. And I would say that primarily the reason that they said that to us was because they were operating from the assumption that the way you do science is randomized replicated trials with one variable. Let's do more copper in these trials and less copper in those trials. Let's do more, zinc, whatever the material is, this variety versus that variety. Apparently there's some students at Cornell just did a research project with cake where they had very, very controlled environmental conditions, and they had multiple different varieties of kale, and they found a 2.5x, variation in antioxidants in kale based on variety. And we said, great. I believe that variety has a effect on antioxidant levels in kale. We found a 250x variation in antioxidants in kale. So let's say that one order of magnitude is the variety. Another order of magnitude is management. Another order of magnitude is environmental conditions. How do we discern that and digest that and then share it back out with growers globally so we can help them do a better job, which we think will correlate with increasing soil health as well as increasing plant health and nutrient levels. And it's a big project, but it seems like we're finally getting enough data to actually have something to share. So that's exciting.
Very exciting.
If I could just comment briefly on NOFA's involvement and partnership in this, and sort of where Jim fits in, sort of what our big picture is what's been really exciting about working on this project with Dan and with the RFC is that in our 10 farmer cohort, of which Jim is a part, as well as being part of our conservation innovation grant, what we're doing is we're contributing these samples into this larger data set that the Real Food Campaign is analyzing. But then even within our little cohort or our learning community of farmers, what we're doing is sort of looking at our results, and then I'll do things like take the USDA averages for different crops, mineral levels that Dan helped me track down, and then track each farmer's sample results against those averages to just give them an idea about where their nutrient levels are, so that they can then look at that, at their outcomes with the other farmers in the learning cohort, and they all agree to have transparency between them, and then they can sort of make observations like, oh, like Jen, why are you getting such high polyphenols and nutrients on your carrot crop? Like what is it that you're doing specifically? What can I learn from you? It's sort of just a little step up from the traditional farmer model of just like, oh yeah, I did this thing and it worked well, I liked it, so it's just a little bit of more data added to that anecdotal farmer community learning process, where we can just add a little bit more data and quantification to that. And so similarly, the CIG project, which Jim is also part of, if the farmers are doing they're trying different methods of tillage reduction, and then we're actually tracking things like what's your infiltration rate doing this year compared to last year? Like how is your compaction? How is your soil structure? So, our theory of change and the connection between these projects is really just like, how can we support farmers in their farmer to farmer education to just have a little bit more quantification in their anecdotes? So I just wanted to chime in there and say a little bit why these projects are important to us and how we're using them, and how these partnerships are so beneficial for us and our farmer communities.
And as I recollect, what we were able to say was to farmers, look, your kale has 3 times the USDA average of calcium in it, or whatever. And those are things one could think that you could market as a CSA grower to your consumers. Like, you may be buying organic kale from Whole Foods in the grocery store or whatever, Trader Joe's. But that bell curve I showed you, the USDA averages really actually do show up at the peak of the curve. Like we did this with 2019 data with all the elements, and it was, in almost every single case, what the USDA says is the level of calcium in a carrot is effectively at that peak of that curve. So what we say is, if the peak of the curve is at the 15th percentile, that means almost all food is junk, right? Almost all food is relatively empty compared to what it could be. And so any grower who's doing a better job, who's, maybe they're only at the 45th percentile, they're still 3x over the average, over what's normally available. And so to be able to say, I don't need to be perfect, I don't need to be the 85th or 90th percentile of what could be, if I'm at 50% of what could be, I'm still 3 times better than everything else that's out there in the supply chain. And that's really what we're trying to accomplish, is to support people in discerning that, finding the growers that are doing a better job, even if it's not perfect, supporting them economically, and sort of, raising all boats. Our objective, increasing quality in the supply chain, is not just for rich people, it's for everybody. If we start to compete on quality as opposed to on volume, then, you know, hopefully the average level of nutrients in food across the board will increase. So, yeah, I'll stop there. But
well, we have some time now to open it up for some more inquiry, and I have a couple of questions about the Johnson Sioux bioreactor. So I thought we could just go back to talk about that. Jim, do you want to talk about how you construct your reactor?
So the Johnson Sioux Bioreactor was developed by David Johnson and his wife, I believe Elaine Sioux, and they were looking for a system that would manage initially dairy manure in a way that was produce an effective finished product without a lot of aeration. So they want a static aerated system, wanted it to be essentially odor-free and produce a fine finished product that was higher in microbial activity. So all this, it's very simple. The actual materials cost under $50. You can meet perforated 4-inch PVC pipe. So you just need 6 of those, and then you'll see the pallet on the bottom, which just has 6 holes in it. And then there's remesh, which is just the sort of a wire mesh that's used in concrete. It's very inexpensive. And then some landscape fabric. So in the back there, you can kind of see the remesh surrounding the landscape fabric. We set that on top of the pallet, drop in the PVC pipes, support them with just wires to hold them in place. And then we feel that there's a whole variety of materials you can use, but wood chips, leaves, leaf mold, broken down hay, basically very similar to what you would use in a regular compost pile, but without a lot of the green material that could end up. This is going to be a static pile that's going to sit there for an entire year, and so anyway, we would layer in the wood chips, the leaves, the organic dairy manure, and then inoculate it with some of our existing compost. And yeah, within a year, the pile is broken down. So the sort of the innovative component in this is that because of the hole in the bottom of the pallet there, and the PVC pipe, you have no area in the compost that is further than a foot away from aeration. So the pipe is in there only temporarily. After about 2 days, there's been enough of hyphae formation and other microbial activity to stabilize all the materials. So you pull out the PVC pipe after that, like 2 days, 3 days. There's a piece of wire on top, and we just grab it and pull it right out of the pile. So then those holes stay in place, and then we do have. You can put in an irrigation system. We chose not to because it was a kind of a wet year, and we would just irrigate whenever we watered our high tunnels. But in the Johnson system, he has an irrigation system that waters for 1 minute every day because they're in the dry desert Southwest, and that's a little bit more important. But we had a nice finished product without having to do that. So the question, what types of microbial life and fungi are we getting in there? We did not have the means to do an analysis. So I mean, just relying on Johnson's work, he was finding upwards of 40 times more microbial activity and more diversity than in a standard compost pile, with heavy fungal dominance. Now, whether that was endo, ecto, I'm not sure. I'd have to look back into his data. So we, unfortunately, like a lot of farms, because we're a working farm trying to make a living, we don't necessarily have the time to go in and look at that kind of detail. So I'm sorry, I don't have the answer in specific to that question, whether it's endo or ecto going on with the fungi.
Thank you. It's one of those things that I ask because at some point somebody will be able to tell me, but so far, but I thought I would ask. Thank you.
Yeah. So there's a great website that's out there for construction of this, and I haven't found extensive research on the follow-up on what types of microbes and fungi are actually going on in there. It just cites the numbers 40 times more, and that's, I'm sure he's got research papers out there. I just haven't been able to find them or get a hold of them. So that I should talk about the finished product is very different than, we make a lot of our own compost, and I've made compost for over 40 years. But this product is very different. It ends up being a lot of the, I would say probably about 65 to 75% of it ends up being almost like a paste, very fine consistency and almost paste-like. And then there is, as you can see on the top there, not all the wood chips break down. So typically around the edges, we found more coarse material. So the fine paste, we would mix into a liquid slurry and then filter with the filter cloth and put into a backpack sprayer and spray that on. So it acts more as an inoculant than as a soil amendment like a normal compost would be. And then we would use the rest of the material also as an inoculant, because there wasn't, you look at it, it's about 5.5 to 6 feet tall, approximately 4 feet in diameter, and it does break compost down to almost half. So you don't have a huge amount of material, but it is pretty much hands off. You set it, forget it, you're not turning it, and you have a beautiful product when you're done. So anyway, we use the coarse material as well as sort of inoculant, sprinkling that on our system, on our beds.
And do you have multiple bioreactors going at the same time?
As I said, we made 4 of the kind of setups with the pallet. The pipes renewal are once you make one, you can use it over and over again. So if we're going to make multiple piles, if you will, or cylinders, we'll make one, wait for the holes to set up, pull those out, and then and then kind of work our way down the line. So in 1 year, the first year we were able to make 3 of them. And this year we've got 1 made, and we'll make another one this fall. But it actually, it probably would be beneficial to be able to stagger the use as well, because right now we're getting our beds ready for next year. We could be inoculating at this time as well.
There was one specific question about the hay rake and about where you were getting it. Would you mind touching on that? Sure.
So BCS originally started out as an Italian company, I believe. It was a delay. And now they have a branch in America, and they're starting to make more and more their own equipment here. But most of the original equipment and the equipment that I have is all European, mostly Italian. The hay rake is from a company called Molon, M-O-L-O-N. I'm not sure what country it originates in, but it is over in Europe. It's sold here through Earth Tools, which is I would say the premier retailer for all BCS and Grillo equipment. Grillo is the other walk-behind tractor that's in Europe as well. Yeah, it's Earth Tools that are out of Kentucky, and they're just fantastic. Great. They have the best prices, and they'll talk you through any issues you've got with anything. And they're also developing equipment as well and improving on things. It's a great company. So they're got both the baler and the hay rake through.
Great.
There's also, we didn't really talk about, but they make a roller crimper for the BCS for terminating with crimping. You've probably seen the bigger roller crimpers that are sort of tractor mounted and huge, heavy pieces of equipment, but there's one that fits on a 30-inch bed that you put on extra weights to get to 100 pounds, and it's got it rolls and crimps your cover crop as well. We've been experimenting with that, haven't quite perfected it, and part of it's just our time. There's a picture on the right-hand side. That is, when you go online to look, there's some YouTube videos of one they used to have it be a front mounted piece of equipment, but it was really too squirrely. It was hard to control where it went. So they switched it to be a rear mounted device. Now, the weights aren't in this picture, but you can see sort of the cylindrical well, and you put on just like old, like everybody's got leftover weights from when their kid moved on to college. They're just weights that, barbell weights that get put onto the inside there, and to get up to about 300 pounds. Because that weight's important for the crimping.
Yeah, and then as you were mentioning it, there's also a time aspect to crimping. Is that right?
Right. So you want to get it at the milk stage. So at a point when the plant is going to be able to be terminated by the crimping. If you go too early, it's actually able to sort of come back to life, if you will. And if you wait too late, the quality of the material laying down isn't as good. It's more fibrous. And also you're going to be dropping seed at that point, which you don't want either. You'd be dropping viable seed. So you want to get it crimped and laid down at a time when the plant is still somewhat succulent in that milk stage, but where the seed isn't going to be able to regerminate if it's dropped when you roll it. So also you need to have a really nice, dense crop to roll down, because the idea is that you can lay this down and plant into it. So you've got rooted mulch in place, and if you don't have a dense enough crop, it works, and you're able to plant into it nicely, but it doesn't last the season. So it'll start to break down and allow weeds to come through if it's not a really dense crop.
Mm-hmm. And there's another question about different scales of crimping. Is there something you can recommend for the garden or smaller scales?
Oh, so here, let me, can I share my screen?
Sure.
I think I'll bump you out if I do, but let me just jump in. I've got a picture here I want to show you that is really ideal for the home gardener. So here in the lower left-hand, this is roller crimping at all different scales. So this is Rodale developed these big tractor mounted front and rear roller crimpers. And you can see the BCS one in the lower right-hand corner. In the lower left-hand corner is, this is a very simple human-powered technique for, I wouldn't call it roller crimping. I'd call it maybe laying and crimping. It's just a 2x6, and then at the bottom of that, underneath, you can't see it, there's a T-post. So that's bolted onto the bottom of the board. So you get the rigid, the metal top, the metal ridges there that are actually doing the crimping, which keeps any fluids in the plant from being able to move back and forth. So they have that T-post across the bottom. It's a piece of rope that to move it along. So they'll slide it forward, lay down that rye crop, it looks like, and then press down and crimp the crop. So that's a really nice way for very inexpensive and sort of appropriate scale for a smaller situation.
That's great. We had another question about the double disc opener and on how have you had success or challenges with different levels of debris on the surface of your beds? How have you found the double disc opener works through debris?
Quite well. I think the hardest thing is going into a bed where we've left stumps. So typically lettuce, but if you do have kale left over from, like, we'll cut our any of our brassicas off at ground level in the fall and then come back in the spring, and you still have a nice hefty stump there. So working through or around those is challenging, but if it's just something like we'll go in a flail mow a crop and then go in afterwards and do seed the next crop, then the double disc opener works fine. We have moved a little bit more towards to transplants, to plugs. So we use the Windstrip 72s, which create just an absolutely gorgeous, long-lasting plug that gives you a lot of flexibility. So we'll go and just dibble into a bed and put in our plugs top of something that's been flail mowed, and that works very well. Because we're trying to accelerate our time frame and not have any downtime or waiting for a crop to germinate, the plug system has worked really well. So we still do some direct seeding into a mulch bed, into a flail mowed bed, but not as much anymore, as we try to maximize our productivity.
And I think we may have touched a little bit about tarping. Do you use tarps also as a form of cover crop termination?
Yeah. Well, it depends on what the crop is. So we use tarps extensively for opening up new ground, which seems to be doing every year. So we'll tarp for, like right now, we'll be putting down tarps over the fall and winter so that we can come in the spring and prep our beds right away. We'll also use the tarps and more so moving to landscape fabric as a placeholder in the middle of the season. And then also in the spring, if we have a cover crop, we use a winter kill cover crop as much as possible, but if we do have a rye, we'll use the tarps early in the season to try to terminate that. Since lately this year, we've had more success if we flail mow first. So we'll take and flail mow that crop, like a rye vetch, twice, and then we'll flail mow it, let it start to come back, and then flail mow it again, and then tarp it. And then usually within 2 weeks or 2 to 3 weeks, depending on how warm it is and how late in the season is, we can come back and plant directly into that. We spent a couple of years trying different ways of termination, and rye vetch is pretty tricky just with a tarp or without 2 flail mows. We used to do flail mowing once, and then a heavy, like a 2 to 4 inch layer of compost and planting into that, but the rye would still come back. Until we went to 2 flail mowings and the tarping, then we're it's rock solid. So the reason rye vetch versus the winter kill cover crop, and we have a nice mix that we like on the winter kill. And the problem is just because our season runs so late, commercially, our markets and our CSA, it's tough to get beds cover cropped early enough for that winter kill mix to get big enough that it's going to do a good job of protecting the bed over the course of the winter. So we do still use rye vetch. For the last 2 weeks, we've been putting on rye vetch as opposed to the winter kill. And so those beds are going to, they take a little bit more work in the spring.
So with that, I want to say thank you again to Jim. Thank you again to Dan for joining us tonight. And I look forward to seeing you again in another event.